This is an applied maths question, specifically a mechanics question. It's taken from the modular series, so M2, and it's June 2010, and it's the first question on that paper. So we've got a particle P moves on the x-axis. So this tells us that it's motion in a straight line. The acceleration of P at time t seconds for positive t is 3t plus 5 meters per second squared in the positive x direction. Now this tells me that since my acceleration is a function of t, it's variable acceleration, which means that we can't use the Suvat equations. So the Suvat equations should only be used when you've got constant acceleration. So next bit of information in the question says when t equals 0, the velocity of the particle is 2 meters per second, also in the positive x direction. And when t equals capital T, the velocity of this particle is 6 meters per second. And for 6 marks, we're asked to find the value of this capital T. So, we have acceleration as a function of t, and we need to find velocity. So we're using calculus when there's variable acceleration. So specifically, the velocity at any time t will be equal to the integral of the acceleration with respect to t. So I can put my expression for acceleration into this integral. So my acceleration is 3t plus 5. Nice simple linear function to integrate. So I add 1 to the power, divide by the new power. Similarly for constants. And really, really important in these questions is to include your integration constant, because this integration constant is going to be found. It's going to affect the value of the velocity at all of the times. So that's what we need to do next. We need to find this value of the integration constant. And we use this piece of information here. When t equals 0, the velocity is 2. So what does that say? So when t equals 0, the velocity is 2. So that sentence in maths, if you like, is v of 0 equals 2. So I'm going to put t equals 0 into my expression for v and set it equal to 2. All the zeros at the beginning, this just simplifies down to c equals 2. So far, I know that my velocity with respect to time is 3 over 2t squared plus 5t plus 2. So this is my velocity at any time. And so the point of this question is to find the capital T, and I'm going to use this sentence to do it. So when the time is capital T, the velocity is 6. So in maths, that says v of capital T equals 6, which I can write as 3 over 2 capital T squared plus 5 lots of capital T plus 2 is equal to 6. And that is a quadratic in capital T, so we need to solve this in the usual way. So we get one side equal to 0 by subtracting 6 from both sides. And I'm going to multiply both sides by 2 because I don't like this fraction in my quadratic. So making sure I multiply everything by 2 gives me 3t squared plus 10t minus 8 equals 0. And just having a quick look at that, I can indeed factorise. 3 is prime, so it's going to have to be 3t on one side and t on the other. And I have a minus 8, so I'm going to need a plus and a minus. And I'm going to put the positive here to make, it's going to give me 12t, so it's a positive 10t. And if I put a minus 2 there, that gets rid of the extra 2t that I didn't want. So you can multiply that out to check that if you'd like, but of course solving in the usual way, this tells me that capital T is either 2/3 or -4, which we rule out because that is a negative time. So we've got this capital T being equal to 2/3, and that finishes the question. So if you'd like to practice some more mechanics questions or investigate some more variable acceleration, then check out studyworld.com.